Hopefully you haven't had to use a whatever it's called, Proctorio, whatever. I would hate that. Ouch, you guys did. It sucks. Yeah, I would feel like extremely anxious if I had someone looking at me the whole time and, you know, okay, I'm looking over. I'm not cheating, I swear. Okay, so today we're going to go over the last part of chapter 2. Chapter 2 again is arrays. So we only have a few slides left. I thought we had more, but we actually don't. So it's really just going over polynomials a bit. And then after that, I'm going to give like a little, I guess, a brief demo of how to import data in Matlab and how we can kind of manipulate that data. Because you'll be doing that for your project. I'll have more details on the project maybe next week. I still need to figure out exactly what I want to do. But in general, for the project, I want to have you can kind of think of it like a data visualization kind of thing. So I want you to have some data. We're going to import the data in Matlab. We're going to have to manipulate that data. So you might be doing, like array transposing, array addressing, array concatenating, stuff like that to get the data exactly how we want it in a way that's manageable to post-process the data and then plot the data. So, the main things that we've gone over so far in this class, or we're going to go over, are arrays and then plotting. So, that's the plan. Today's going to be pretty loose, though, since we're almost done with chapter 2. So, seems like some of you are, not feeling great about the quiz. So we're going to go over the homework first. Yeah, I'll pull it up here. Okay, and this is what I have open right now is basically what we're going to go over later. To be honest, I kind of got carried away last night with this project, well, demo. I'll actually show you it really quick since we have time. So basically, I took some data, if anyone's a baseball fan, I took data from Baseball Savant for average exit velocity for hitting a baseball, and then on-base percentage. And then I made a plot. So we'll go over it later, but this is the plot that we're going to make. So yeah. Okay, so the homework. So again, since we have time, we're going to go over everything just so you guys can be better prepared for today's quiz. I'm going to make this a bit bigger. Okay, so the first problem was kind of review really from what we already learned before. So we have to make the following matrix from row vectors. So you guys should have seen the solutions that were posted as well on Canvas. Okay, so we have to make this row or this matrix A from row vectors. So, this should be very easy for you by now. So we're just gonna define it from row vector. So we're gonna have the first row, and then we'll use a semicolon because now we want to start in the second row, and then we'll define that. And then we have our matrix A here. So that should have been very simple. Okay, problem 2. We want to build this matrix by filling in the blanks. So what I already had R and S defined, and then I had you fill in the blanks for T and B. So we'll do, we got to make it like this. All right, so we have R is 12, 20, and 2. Oh, sorry, 13, 20, and 2. Okay, so we can see right there, R is 13, 22, and S is -2, 12, and 1. So we can see that those are the first two columns that we have in this matrix. So right now we define them as row vectors. So later on, we're going to have to transpose them so they can be column vectors. So we'll define S. Again, R and S, they were given to us already. Okay, and then we have to fill in the blank for T and for B. So just following, the pattern that we already had here. T, that's going to be the third column here. That's 7, 5, and 50. And again, we're first defining it as a row vector. Okay, now we have to make the matrix B from the three variables that we already have. Is the quiz from this homework? Yeah, the quiz is mostly based on what we did in the homework. I think there might be, one or two questions that aren't on the homework, but they're going to be what we went over in class. And it should be pretty straightforward, I think. But most of it's based off of the homework. And just to clear some anxiety, if anyone's worried that we're going to have a question on vectorized functions last time, if we were multiplying cosine of x times sine of x and you have to use array multiplication, that's not on the quiz. Yeah, I try to make all quizzes based off of mostly what we had in the homework. Yeah, it's the material's up from Wednesday last week, I think. I forget where we left off, but yeah, most of it is on this homework. Okay, so we're gonna finish this, and I'll talk about the quiz before we start it too. Okay, so now we have to make this matrix B from what we already have defined. So we're just gonna do R transpose, S transpose, and then T transpose. Okay, so all we're doing is transposing each of these row vectors into column vectors now. So then if we press enter, then we get that matrix B. Okay, so hopefully that's another pretty easy one. Okay, now we want to define this regularly spaced column vector, and we're going to do it on one line. So all you have to do is v equals -10, then we'll use our colon operator. So I have intervals of +2, so it'll be +2, and then we're ending at a value of 204. And then, yeah, Richard, I get to your question in just a sec. Okay, so right now this is a row vector, and then I would have to transpose it because we want to have a column vector. And really I should suppress the output here, but I won't. There's our column vector. So going from -10 to 204. Okay, so Richard is asking from question 2 if we could define it a bit differently. So if we could do B equals R S T and then transpose that entire matrix. Oh, I cleared everything, of course. Yeah, you could do V as a second step instead of all in one, but you always want to be as compact as you can, if you can still be explicit in what you're defining. Okay, so I'm going to go back to question 2. Okay, so Richard is asking if we can define it like R, S, T. Okay, so then we have this, we would have this row vector, okay? Oh, sorry, you actually, you had it with semicolons here. Okay, so we have this matrix here, and then if we transpose to that matrix, then yeah, we get the same. So that would work as well. And that could be, a little more convenient so you don't have to transpose each individual vector. Okay, but if you did it like this, if you did it like B, comma, S, comma, T, and then you transpose that, that wouldn't work because right now we are appending the row vectors S and T to R. So here we just have one really long row vector. So if we transpose that, we just have one really long column vector. So yeah, Richard, you'd have to do it just like you defined it. Can you use linspace for question 3? Yeah, you could do linspace, but you would have to know the amount of elements that are in the array. So let's go back here. So 3, we had v equals -10, 2 to 204. Oh, also, you'll see that I wrapped v inside of brackets when I transposed it. So let's first define v like this, so we can do that, and then I can just transpose v, and that works. But if I was trying to do all in one line, and I tried to transpose it like this, then that's not going to work. Here we have a row vector still. Our transpose operation didn't work, and that's just because we need to wrap this inside of brackets if we're going to do on one line. And then that works.
So what's the difference between putting it in brackets versus doing it in the parentheses?
Parentheses, I think that works too, but typically when we define a vector, by convention, we put it in brackets. So yeah, parentheses works too, but convention is using brackets.
Okay, cool.
Okay, so the question is, can we use linspace? So you can use linspace, but again, you need to know the amount of elements beforehand. So here we're going from -10 to 204. At least I can't figure out how many elements that is in my head. So we would need to know the length beforehand. So the length of that vector is 108. So if we knew that length beforehand, we can define the same vector using linspace. So we could do, I'll call this v underscore lin. Then we could do linspace. We're going to start at -10. We're going to go to 204. And then our length is 108. That should be a comma. And so we defined it, but in this case, it's a row vector first. So we would have to do v underscore lin equals linspace, and then we'd have to transpose it. And then there's our vector. Yep, you're welcome. All right, just seeing how many questions we have, I forgot. Okay, so question 4 now. Okay, so big hint here. This is going to be similar to one of the questions on the quiz. So if you're going to pay attention, make sure you pay attention here. Okay, so we are given the following matrix D. And I think in the quiz, actually, on the top of my head, I forget if I have you define the matrix yourself or not. I know in one question I do, but if it's a big matrix, maybe I'm not making you, actually build it. But we are going to have a question on array addressing. So yeah, make sure you pay attention here. Okay, so let's first make this matrix D. So I always personally make my matrices row by row. Kind of a big matrix. Okay, so here's our matrix. So we need to specify the following: the element in the third row in the second column, all elements in the third column, rows 2 to 4, columns 3 to 4, and rows 1 and 3, and columns 2 and 3. Okay, so we'll start out on A. So we need to specify the element in the third row in the second column. So we're going to go in the third row and the second column. We need to get the output for 66. So I'm going to just call this D underscore A because we're doing part A. And to do array addressing, I need to first specify the array that I want to look at. So in this case, that's array D. And remember, an array is just some collection of variables. So an array can be a matrix or it could be a vector. So we're looking at array D or matrix D. And then I want to get the output for row 2, or sorry, row 3. So I'm going to put a 3, and then I want to look at column 2. So I'll do comma and then 2. And then our output is 66. Okay, now we want to look at, is there a
If you just
question?
put D equals and then in the quotation, in the parentheses 3 comma 2, would that work? D
So
equals?
you're saying like
Yeah.
this?
Yeah, would that work?
That wouldn't work because we're not specifying what matrix to look at. Right now, we're just assigning this variable D to 3 comma 2. And it won't even let us do that. Okay, so yeah, if we're doing array addressing, we always need to make sure that we specify first the array that we're looking at. So you have to put in your array, whatever it is, and then you're going to use parentheses and specify whatever it is you want to look at. Okay, so this question, is it always in the format row, comma, column? Yeah, that's the case. Yeah, it's always m, comma, n, where m is the row, n is the column. All right, so we'll do part B now. So we want to look at all of the elements in the third column. So I'm just going to call this B underscore 4. Or I guess D, whatever. It doesn't matter, just some variable. Okay, and then we want to look at all of the elements in the third column. So I want to get all of these elements here. So I want 34, 15, 303, negative 11. So I'll do D. Here I'm going to use a colon. Remember, a colon means take everything. So because I have the colon as the first argument, that means take every row. So right now it's taking every row here. And I need to tell Matlab which columns I want to look at too. So I'm going to do comma, and we want to look at column 3. So I'll put in a 3. And then we have all of the rows in column 3. So we have this row, this row, this row, this row. And we're inside of column 3. Okay, would I deduct points if I did part D like oh, so you're looking at part D already. So I'll get to that in a second, and then we'll talk about it. Okay, so we'll do part C. So part C, we want to look at rows 2 to 4 and columns 3 to 4. So I'll do C underscore D. I'll just follow the format I had it for my solutions. Okay, so we're looking at the matrix D. We want rows 2 to 4. So in this case, I have a range. So I'm going to put 2. I want to start at row 2. And I'm going to use the colon operator because I want to have some range. It's kind of similar to how we define a row vector when we're using the colon operator. So I'm going from rows 2 to 4. Now I need to specify the columns I want, so I put a comma, and then I want columns 3 to 4. All right, so now we have rows 2 to 4. So we have 2, 3, 4, and then columns 3 to 4. So 3 and 4. So we have this right here. Okay, part D. So first I'm going to go over my solution, and then I'll look at yours, Victor. So we have D underscore D equals. So here I'm defining it, so I want to have, let me see what we're even doing here. Okay, so we have rows, we need to have rows 1 and 3 in columns 2 and 3. So I need row 1, I need row 3, and then I need columns 2 and 3. So here, so I need 10, 34, 66, 303. Okay, so I'm going to define it. I'm going to wrap it in brackets because I want to make this kind of matrix here. So I'm going to start out by doing, looking at row 1. So I'm going to put 1. Then I'll do a comma, and now I need columns 2 and 3. So I'll do 2 to 3. Okay, so now we have row 1, columns 2 and 3. So here's row 1, columns 2 and 3. So we have 10 and 34. Now I need row 3, columns 2 and 3. So now I need the values 66 and 303. So I'm going to do a semicolon. So here, and this is actually kind of similar to your question. I didn't specify whether I wanted it to basically be like a matrix or not. So I would be more clear in the quiz, but let's just do what I have here. So we want row 3, and then columns 2 to 3, and then I'll end the brackets. And we get that kind of sub matrix. Okay, so Victor, if I do it your way. Okay, so Victor, I'll first do it your way. So you have d underscore d equals d 1 comma 3. Then you have 2 to 3. Okay, so yeah, that works too. So you did it just by having first just 1 comma 3 and then 2 to 3 with that kind of range. So that would work as well, and I wouldn't mark you down for that. Okay, so yeah, for some of this stuff, there might be a few ways that you can do it. So if you can still do it, in a different way, and you get the same output, that would be fine. I'm only going to mark you down for stuff like, let's say, for question 3 here, if you defined it by, like if I said do it on one line and you tried doing it on multiple lines, then you would be marked down because I asked you to do it on one line of code. So I try to be explicit on the quiz, at least for what I want you to do. Okay, so we have another question too. So for part D, what if it asks for rows 1 and 3 and columns 2 to 4? Or 2 comma 4. Okay, so we have rows 1 and 3, and then columns 2 and 4. So I want rows 1 and 3, and then 2 and 4. So we want 10, and we want 77, and 66, and 12. All right, so I'm going to try to do this on the fly here, trying to think about it while I go. Okay, so rows 1 and 3, I'm just trying to put this in my head here. Okay, so we need, so we're going to address D. I already cleared it. Let me put it back. Okay, so we'll do, we need the first row, and then we need the second column. So I'm going to do it like that. So I want to have, I'm going to look at the first row here, so I'll put a 1, and then I want the second column, I'll put a 2. And if I just put this right now, then we have that value for 10. Okay, then I can do, I'll do row 1 and then column 4. So I'll do D and then 1 comma 4. Now it's now going to give us 77. Now if I wanted to like make this kind of a matrix, so if I wanted 10, 77, and 66 and 12, I could do that by putting a semicolon. So I'll do D, and we want 3 comma 2, since we're in the third row, and then we want the second column. And then D 3 comma 4, and then I get that kind of submatrix. So we have 10, 77, 66, and 12. All right, so hopefully that answers your question too. There might be another way you can go about it. Again, if you get that, I would still give you full points. Okay, so matrix E. I think I have a question like this on the quiz as well. Pretty sure I do. Okay, so I'm going to make this matrix E first. And again, it's another kind of big one. All right, there's your matrix, and I want you to create what I think I called it a submatrix. I guess I didn't. Whatever. But I want to make the this matrix here that contains the values -22, 8, 77, and 54. What did I mean when I said which contains the rows and columns from the parent function? So, see, I said parent matrix E, so I used it in quotes. Basically, you know, the parent matrix would be this matrix E right here. So I'm saying which contains the values from rows 1 and 2. So we're looking at rows 1 and 2 in this, in quotes, parent matrix. So rows 1 and 2 and then columns 2 and 3. So I'm looking at these 4 values right here. Okay, so I want to make that kind of sub matrix. Again, the word I'm using doesn't really matter. I just want to make some new matrix that's containing these 4 values here. So I can use, you know, any variable name that I want. Call it apple. Okay, so I want to look at matrix E. So I'm going to type in E. Then I want rows 1 and 2. So I'm going to do 1, 2. I want to go from row 1 to row 2. And now I need to specify the columns I want. I want to go from column 2 to column 3. And then we get that quotes submatrix. Okay, so what time are we at? 10:30. Okay. All right, so we have the following row vectors. So we have a row vector R, 12, -3, 92, and a row vector S, 3, 4, -130, -9. You'll see I put a 0 in front of 3 and 4. That doesn't matter. It's the same thing as just 3 or just 4. I'm just kind of making it. I tried to get it to line up with this top matrix a little better, but didn't really work out. Okay, so we need to complete the following operations and see if they work. So first one is R plus S. So let's first look at the link that we have for these vectors. So we have row vectors, and they're both 1 by 4. So I have 1 row and then I have 4 columns in each vector. So R plus S, because they're the same length here, that's going to work out. It's basically doing element by element addition. So I'm doing 12 plus 3. I'm looking at the first element in each vector here. So it's doing 12 plus 3 is 15. Then -3 plus 4 is 1. 90 plus -130 is -40. And 2 plus -9 is -7. Same thing if I do S minus R, it's going to go element by element. So it's going to do 3 minus 12, -9, and so on. Okay, now we're getting into the kind of the meat of our understanding. So that being array multiplication and matrix multiplication. So the first thing we have to do is array multiplication or element by element multiplication. And we're doing that for R times S. So that's going to be R. And since I asked for array multiplication, we have to put in a dot. So we're going to do R dot star. And this dot star, just to really put it in the ground, is array multiplication. So we have R dot star S. Does that work? It works because our row vectors are the same length. They're both 1 by 4. Because they're the same length, it can go element by element. So we're doing 12 times 3 is 36, -3 times 4 is -12. 90 times -130 is -11,700, and 2 times -9 is -18. So if you look at that, you can see that we're going element by element here. All right, the last part, can we do R times S using matrix multiplication? So we would type it like this, just R and then times S. Doesn't work. Why? Our dimensions aren't compatible. So here I'm trying to do matrix multiplication of 1 times 4 and 1 times 4, where that's the dimension. We have a 1 by 4 row vector and a 1 by 4 row vector. This isn't going to work because these inner numbers here, they aren't the same. 4 and 1, they aren't the same. The columns of our first matrix need to be equal to the rows of the second matrix if we're going to have a matrix multiplication. Any questions on that part? Okay, so question 7, this will be another question that's on the quiz, something very similar to this. Okay, so we're going to make our matrix F. Geez, I made so many big matrices here. Kind of annoying. All right, there's our matrix. So we have two things we have to do. We're going to find the maximum and, oh, I guess really 4. We have to find the maximum and minimum value in the third row and the max and min value in the fourth column. All right, so we'll look at the max value in the third row. So to look at the maximum value of some vector or some array, I really should say, we need to use the max function, and that's just max. So I'll type in max, and now I want to look at the maximum value in the third row. So here, yeah, okay. I was looking at wrong at first. Okay, so we're going to look at the max value in the third row. So we're going to put in a 3 because I want to look at the third row. So I need to put in an F though because I want to look at that matrix F, and I will put in a 3. And I'm going to put in a comma and then a colon because I want to look at all of the values in that third row. And then the maximum value in the third row is 13. Is that correct? Yeah, that's right. All right, the minimum value in the third row, we could just do this too. So I just need to change that to min. So to look at the minimum function of some array, we just use the min function. And then we get 6. That's correct. All right, and then it's the same kind of thing for column 4. So I'm not going to go over that part just because, again, it's the same thing, but we want to look at that fourth column. All right, question 8. Question 8, this will be on the quiz. Not this exact question, of course, but something like this will be on the quiz. All right, so we got to create a 3-dimensional array called G with the following layers. So, all right, got a question. What if we wrote something like third row equals F3, comma, colon? So yeah, let's, we'll go back and actually carry out exactly what you're saying. So here's our matrix. And Fabiola is saying, can I do third row equals F3, comma, colon? So that's going to give us everything in the third row. And then do max of third row. And that'll give you 13. Yeah, you could do that if I didn't restrict how many lines you had to do it on. In the quiz, I do it by fill in the blank, so typically I have you do it just on one line. Okay, so problem 8. Again, this will be on the quiz, something like this. So remember, a 3-dimensional array or a multi-dimensional array is composed of many arrays, as you would think, and they're composed of different, in quotes, layers. So we'll make it, and then you can kind of visualize it a bit better. Okay, so our multi-dimensional array, it has to consist of 3 matrices. So great, we're just typing out a lot of matrices here. Okay, there's matrix A. Make matrix B. And matrix C. If I like mistype a number, I'm not going to worry about it either. All right, so we have our three matrices, and now we need to make this using the cat command. So here I don't specify, but in the quiz, I'm making you make the multidimensional array using the cat command. So make sure you're paying attention. All right, so let's make that multidimensional array. So I'm gonna create a variable. Oh, we want to call it G. So okay, so we're gonna have G equals cat, and then I'm gonna put for the first argument, I'm gonna put a 3. 3 that specifies our dimension. So for a multi-dimensional array, that's using a dimension of 3. And then we just have to put in the matrices that we want to in this multi-dimensional array. So that's A, B, and C. If we press enter, then we see that we have our multi-dimensional array. So on this first layer, we have the first matrix. Second layer, we have the second, and the third, we have the third matrix. All right, any questions on that? Okay, and then let's see, we got it displayed, the element in the third row, second column of the first layer. So again, we're doing array addressing here. What am I looking at? Okay, so we're gonna look at the element in the third row, second column, and the first layer of A. So we're gonna look at the third row, the second column, and the first layer. So I should have an output of 9. So I'm gonna do A8 equals G. I'm gonna look at that multi-dimensional array G. And then I want the third row, so I'm gonna put in 3. The second column, I'll put in 2. And now I need one more argument to specify which layer to look at. Then I'll put in 1. And then we get that value of 9. Okay, what if we only have 2 matrices? Would it be cat 2, comma A, comma B? No, it would still be cat 3, comma A, comma B. So let's call it H cat 3, comma A, comma B. And then that'll give us those 2 matrices. Having a dimension of 2 is, I think it's the same as appending a matrix below. Let's just do that now. So we'll do cat 2, comma A, comma B. Okay, it's to the right. I was wrong. But basically, if I used a dimension of 2, it took our matrix A and it put it right there. And then it appended our matrix B to the right of matrix A. If I did a dimension of 1, then that's going to put the matrix B below matrix A. And then you see it does. So if you're making a multi-dimensional array, you need to make sure that the first argument in the cat command is 3. That's a dimension of 3. So just make sure you put in a 3 and you'll be fine.
I have a question. Since you didn't specify about using cat, could we just have done A and then parentheses 3, comma 2 for the first one?
No, just because I want you to make a multi-dimensional array first.
Okay.
Yeah, but so I wasn't, as explicit as I thought I was in the homework here, but I know for sure in the quiz, I tell you to use the cat command to make that multi-dimensional array. And then I don't think I have array addressing for the multi-dimensional array in the quiz though.
All right. Thank you.
Okay, so we have a question. If it's appending, is it just that one layer? Yeah, it would be. It depends on what you're appending. So here we did cat 1, comma A, comma B. if I also specified C, then it would add that as well. So you just have to be explicit in what you want to append. I could flip this too. I could have the matrix C first. So I could have C, comma B, comma A. If I didn't show in our output. Let's okay, oh there it is. And so I could flip it where I have the matrix C first. So yeah, if we're appending, we just need to it would be just one layer if you only specified to append one layer. Hopefully that answers your question. Okay, cool. All right. So this isn't on the quiz. So we'll go over that if we have a little time later. Because this is important stuff right here. I actually could have put that on the quiz. I didn't think this was on the homework. Oh well. All right, so we've got one more big question that'll be on the quiz. On your quiz this time, it's 20 minutes too. It's 20 minutes and you have 6 questions, though the amount of work should hopefully be around the same. Okay, so we have to make a matrix A. This will be another question. I think I said it, but this will be a question on the quiz. Something like this. Okay, so we have 2 matrices. We have A equals 21, 7, and 3. Negative 90, 40, 56. And our matrix B, you know what? I want to see the output. Okay, and we have B equals 6, 9, 3, 2, 20, negative 10, negative 80, negative 6, 22, 33, 44, 13. Okay, we got our 2 matrices, so we have 4 questions. First one, can we do matrix multiplication? Does it work? Why or why not? So let's look at this. Matrix A is a 2 by 3 and matrix B is a 3 by 4. That's going to work. So let's just do it first and then we'll discuss why. So matrix multiplication, I'm only going to put in a star. Okay, that works. So when I ask you, does it work? Why or why not? On the quiz, you can just say or the sizes are compatible, something like that. So why does it work? It works because these inner numbers here, they are both 3. So the columns of matrix A, the number of columns of matrix A matches the number of rows for matrix B. So you can see that right here, we have 3 and 3 for the inner numbers. And then the size is going to be 2 by 4. I think that's a question on the quiz. Well, I know it is. So you need to basically tell me what the size will be for some given matrix multiplication. So here we know it's going to be a size of 2 by 4 because our first number is 2 and then our last number is 4. So 2 by 4, and it's going to work because those inner numbers are both 3. Okay, any questions on that? Because that'll be, a question on the quiz. Okay, so then the next one we have is A times B using array multiplication. So A dot star B, does that work? No, because array multiplication, our arrays have to be the same size. Size of A is 2 by 3, and the size of B is 3 by 4. And that's what Matlab tells us as well. So those sizes are different, so we can't do it. Remember, for array multiplication, it's going element by element. Because the amount of elements aren't the same, we can't carry out that multiplication. Okay, next one. B times A using matrix multiplication. Does that work? No, it doesn't work because we have a 3 by 4 and then a 2 by 3. So this time, our inner numbers, they don't match, so I can't carry out that multiplication. Then we have one more, b times a using array multiplication. Again, that doesn't work because the sizes of those matrices, they're not the same. All right, so we got one more question to go over here, and that'll be question 12. So we have two row vectors, r equals 12, -3, 90, 20, s equals 3, 4, -130, -9. Okay, so Shadon, I hope I said your name right. Okay, they have a question. If we have matrix multiplication that was 1 by 2 times 2 by 3, would the resulting size be a 1 by 3? That's correct, yeah. Okay, so for a question we have R and S. Can I do array multiplication of R and S? So that would be R times S. Let's, well, we can already see the answer, but yeah, that's going to work because we have a row vector that's 1 by 4 and another row vector that's 1 by 4. So they are the same size. Okay, so can I do matrix multiplication of R times S? No, I can't because the sizes aren't compatible. So this time I'm doing basically 1 by 4 and then 1 by 4. Those inner numbers, they don't match. What if we did R times S transpose? Oh, I do have that as a question. Okay, well, yeah, so that's going to work. And the size is going to be 1 by 1. So that's going to be a scalar. So we have a 1 by 4 row vector and we have a 4 by 1 column vector because we transposed the row vector for S. So our inner numbers, they match. They're both 4. And then the outer numbers are 1. So our result is going to be 1 by 1. And then the other one we had was array multiplication of R and S transposed. So we have R dot star S transpose. Does that work? Oh, this is a good question here. Hint, hint. Okay, so that's going to work as well. Because the sizes of our vectors here, they were the same. So we can do it. But this time, it's going to be a 4 by 4 matrix this time. So it's still going element by element. But it's doing that like for 12 and 3, and then 12 and 4, and 12 and -130, and so on like that. And -3 and 3, 3 and -4. Maybe I didn't get the order right just now, but I think you get what I'm saying, that it's still doing element by element, but now it's going to give us a 4 by 4 matrix here. Okay. Any questions? Did we skip 11? Yeah, we did, but that was just kind of a trash question. Not really trash, but it would be a better question for chapter 4. But here, yeah, really, you just have to use the end, I should say argument. So if I have some row vector, so there I just made a random row vector. Oops, not that. Maybe I should show you the output. X equals rand, we'll do 20. Okay, nope, shouldn't have done that. Let's just make one. Okay, so I could just do X and why didn't that work? Oh, I put a 0, that's why. 1. I want a step size of 1. X. And then we get that last value would be 200. So yeah, so question 11, that would really be a better question for when we go over chapter 4, because To make this operation more smooth, we would use a for loop, but I'm not going to have a question like this on the quiz. And we skipped this one as well, but we'll talk about this maybe another time because it's not important for the quiz, and and you have to start your quiz like right now, so don't have time anyways. So yeah, for this quiz, you have 20 minutes to work on it, and starting in 3 minutes. Sorry, the time kind of snuck up on me. All right, so go to Canvas, open up the quiz. It's gonna open up automatically at 10:55. And I'm gonna stay in here again, just like last time, if you have any questions. I'm gonna open up the quiz right now just so you can see it. Okay, here's quiz 2. Oh, shit. I shouldn't show you that because I have my answers there too. Okay. Oops. All right, quiz is going to start in 2 minutes, so make sure it's open up on your computer. Yeah, I kind of forgot about that. All right, I'm going to mute my mic, and I'll still be in here though. And I'm going to stop my video too. No, you can leave the call if you want. Yep, have a good day. See you on Monday.